Alright, in this video we're going to talk about tension at different angles. So sometimes you're going to see problems where you have an object that's hanging and you have a string that's tying it to the ceiling and a string that's holding it to the wall. So you have an angle here to the ceiling, and that is the same as the angle to the block. And then you have just a horizontal string. So we need to think about how these are actually pulling them. This string has a certain tension, and that tension is just holding it to the wall. This string, on the other hand, has two different directions that it is applying force to the block. So it has a vertical direction that's holding it up so that the force of weight of the block doesn't bring it crashing down to the bottom. And then it also has a horizontal force that's directing it to the right. Now we always know that there's a force of weight on the object, and that force of weight is always going to be the mass times gravity of wherever the surface or wherever the object is. So my force of weight is what the vertical component of the tension of this string has to counteract. So this vertical component of the tension is going to be equal to the force of weight. So let's call this T2y, and T2y is going to be equal to the force of weight. Now, because it is a component of T2, then it also can be found by using the sine of theta times the tension of 2. Now, when we look at the horizontal aspects, we have T1 that's pulling to the left, and we have T2 that is pulling to the right. So T2x is what I'm going to call this, because it's the horizontal component. And that T2x is going to be equal to T1. If it wasn't equal to T1, then the object would not be stationary, and instead it would be either going towards the right or towards the left, whichever one is greater. So these two have to be equal.